Hello and welcome. In this video tutorial, we're going to take a look at the right triangle trigonometry introduction. In the beginning, we want to practice making sure that we can put the sine, cosine, and tangent of a particular angle in our calculator. Now, before we do anything, we're going to perform a simple test on our calculator just to make sure it is in degree mode. And here's what I mean. If we take our and this, by the way, is an example of what I call a forward calculator. Forward calculators are one where you press the functions and then the numbers. So in a forward calculator, we would take the sine of, let's say, for instance, 90 degrees. Here's the test we're going to perform. If we take the sine of 90 degrees and we get 1, we are in degree mode and we are ready to roll. If you will have a backward calculator like this, you need to press the angle and then sine. Now you'll notice I'm not getting 1 because I'm not in degree mode. So if I try it again, 90 sine, now I'm in degree mode. So the first step is let's make sure we put it all in degree mode. So what I'm going to do is I'm going to be working with a forward calculator for this part of the lesson, but if you work with a backward calculator, please remember to put the angle first and then press sine, cosine, or tangent. Let's begin. I'm going to go down the row, or down the column, excuse me, and I'm going to calculate the sine of 30, cosine of 30, and tangent of 30. Sine of 30, we get 0.5. Sine of 80, I get 0.98. Now you'll see it's 0.48, but since I'm only going to round it to 3 decimal places. Since the 4th digit is greater than 5, then I'm going to take the 3rd digit of 4 and I'm going to round it up to 5. Sine of 45, 0.707. In the next column, I'm going to find the cosine of 30, cosine of 80, and the cosine of 45. Now I'm using the cosine button. So cosine of 30, I get 0.866. Cosine of 80, I get 0.174. And cosine of 45, I once again get 0.707. Lastly, I'm going to take the tangent of 30, tangent of 80, and the tangent of 45. Tangent of 30, 0.577. Tan of 80, 5.67.
Guzman, report to the main office. Valerie
Tangent
Guzman, report
of
to the main
45
office.
is 1. So in this first exercise, we are practicing putting in the sine, cosine, and tangent of an angle. Now in the next exercise, we're going to be taking a look at angle whose sine is. Now in order to do these, we need to know something about how to solve equations. Try to remember what we learned last week. There exist 6 operations that you already know how to do. Okay, let's remind ourselves. You can add numbers, you can subtract numbers, you can multiply numbers, you can divide numbers, you can even square and square root numbers. Those are the 6 operations we looked at last week when we were trying to learn how to solve equations. Well, we learned that in order to solve equations, we have to use what are called inverse operations. In other words, do the opposite of what we see. This is what we see. This is what we do. Inverse operations are the opposite of what we see. So if I see add, I subtract. If I see subtract, I add. If I see multiply, I divide. If I see divide, I multiply. If I see square, I square root. And if I see a square root, I square. So these are the 6 operations and inverses we learned last week. Time for 3 more. Sine, cosine, and tangent. Now, sine, cosine, and tangent are abbreviated sin, cos, and tan. Those are the abbreviations. Now, the inverses of these functions are sine to the negative 1, which is referred to as arc sine, cosine to the negative 1, which is called arc cosine. It's abbreviated arc cos, but arc cosine is what it's called. And then lastly, tangent to the negative 1, which is referred to as arc tangent. So in other words, in these examples here, we are given the sine, cosine, and tangent of some mystery angle. Now, when we see this little symbol here, that symbol is the Greek letter theta. And it's a variable that stands for an angle measurement. It's just a variable we're using. So the sine of some angle, we don't know what it is, equals this value of 0.78. Here's how we're going to solve this problem. I'm going to do example 1 up here, and then we're going to do a shortcut with all of these down below. Okay, here it goes. Arc sine of theta equals, and I'm going to spread this out a little bit, 0.78. Now, look at my list up here. In order to get rid of the sine and to get theta by itself, I need to take the arc sine of both sides of the equation. One thing I will not do, ladies and gentlemen, is I'm not going to divide by sine. Sine is not an algebraic factor. Don't do that, okay? We have to do the opposite of sine. The opposite of sine is arc sine, which is the symbol sine to the negative 1. So we're going to take the arc sine of both sides of the equation. Arc sine cancels with the sine, and theta is now by itself on the left-hand side. And all we're doing in the calculator is taking the arc sine of 0.78. Now to do that, you'll notice the arc sine is right above the sine button. So you have to either press the second function and sine, and then hit 0.78, and you can see we get about 51.26 or 51.3 degrees. Okay, again, on a different calculator, this one right here, let me just do a double check, sine of 90, good, we're in degree mode. Okay, so if I want to do the arc sine on this calculator, I would hit shift sine, and you can see the arc sine symbol show up of 0.78, and you see I get the same thing, 51.3 degrees. I round 0.26 up to 0.3. And again, if you have a calculator that looks like this one you have to go 0.78 first. You have to put in the decimal first. Second function, sine. That's how you get the arc sine. It's right above. You just have to go second function to get it. And you still get 51.3 degrees. So what are we going to do to get these numbers? To get theta, we're going to take the arc sine of 0.78, the arc sine of 0.38, the arc sine of 0.59. To get these numbers, you're going to take the arc cosine of 0.78, because arc cosine is opposite cosine. You're going to take the arc cosine of 0.38 and the arc cosine of 0.59. And lastly, to get these numbers here, you're going to take the arc tangent, because arc tangent is opposite to tangent, of 8.33, the arc tangent of 4.28, and the arc tangent of 0.43. Follow along with me, and let's get these done one row at a time. Okay, so for this first one, we're going to take the arc sine of 0.78. So second function sine, we get arc sine. 0.78 we saw was 51.3 degrees. We're going to round everything to maybe 1 decimal point for this exercise. The second one, we're going to go arc sine of 0.38. And we get 22.3 degrees. And for the third one, we're going to go arc sine of 0.59. And for that last one, where you can see we're getting 36.2 degrees. So there's the first column. Second column, we have the arc cosine. So second function cosine of 0.78. That is going to be 38.7 degrees. Notice all of my answers are angles. We're working backwards. Instead of taking the sine, cosine, and tangent of an angle to get a decimal, we're taking the arc sine, arc cosine, or arc tangent of a decimal to get an angle. We're working backwards. Next part, we're going to go arc cosine of 0.38. And we get 67.7 degrees. And in the last one, we're going to go arc cosine of 0.59. And we get 53.8 degrees. And in the last column, we're going to take the arc tangent of 8.33, and we get 83.2 degrees. Then we're going to take the arc tangent of 4.28, and we get 76.8 degrees. Then we're going to take the arc tangent of 0.43, and we're going to get 23.3 degrees. And so this is how we put the sine, cosine, and tangent of an angle measurement to get a decimal. And it's how we take the arc sine, arc cosine, and arc tangent of a decimal to go backwards and get an angle. Now that we've learned how to use our calculator to take the sine, cosine, and tangent of various angle measurements, or to take the arc sine, arc cosine, and arc tangent of decimals to get their respective angles, now we need to focus our attention on the sides of a triangle and what they're called and how they relate. So as a reference, we're going to use this triangle over here, which is reprinted down over here, as angle A, angle B, and angle C. Now you'll notice the side opposite angle A is little a. The side opposite angle B, well, that's little b. And the side opposite angle C, well, that's little c. But next to little c, I want you guys to write, and we'll do it down here on this same triangle. Next to letter C, let's write the word hypotenuse, because that's what it's called. The angle that's opposite the right angle is always called the hypotenuse. And we can say that it's height for short. Now is where we need to relate these three sides together. To do that, I'm going to write down an acronym, and many of your math teachers will share this acronym with you. And it goes as follows. So, ka, toa. Right? The Native American god of trigonometry. Well, SOHCAHTOA can be split into three sections like this, so that you have a SO part, a KA part, and a TOA part. Let's examine each one individually. SO is an acronym abbreviation where S in SO stands for sine. The abbreviation, of course, is sin, but the word is sine. And that's equal to the opposite side of the triangle divided by the hypotenuse. Ka, the C in ka stands for cosine. And that stands for the adjacent side of the triangle divided by the hypotenuse. TOA, well, TOA is, T in TOA stands for tangent. And that's equal to the opposite side over the adjacent side. Now, what's really important here is that you be able to identify what the opposite and adjacent sides are. Now, before we get into any of this, just a reminder, all three angles of any triangle, A plus B plus C, always have to add up to 180 degrees. Now, why is that important? Because if this is always 90, that means these two angles here must always add up to 90. So for instance, if this is 30, then this angle would be 90 minus 30, which would be 60. These two angles will always be complementary angles, or angles that have to add up to 90. Now, let's take a look at this triangle here with sides A, B, and C, and let's write down these ratios here. So the sine of angle A is opposite over hypotenuse, so that's going to be opposite side A over hypotenuse little c, side C. Cosine of angle A is going to be adjacent over hypotenuse. So this is something we need to get into perspective here, and that is the opposite side of angle A, and this right here would be the adjacent side of angle A. The word adjacent means next to. So you can see side B is right next to angle A. And if we reference angle B over here, well, this side over here is opposite angle B, and this side now becomes the adjacent side. So I want you to notice that as we go from one angle to the other angle, the role of that side becomes switched. What was the opposite side now becomes the adjacent side. What was the adjacent side now becomes the opposite side. So again, the cosine is adjacent over hypotenuse. Adjacent to A is B over little c. Tangent of A is equal to opposite over adjacent. So little a over little b. Now we're going to switch our reference point from angle A to angle B up top. So this side is now the opposite side of B, and this is now the adjacent side of angle B. So sine is opposite over hypotenuse, opposite over hypotenuse, B over C. Cosine of B, that's adjacent over hypotenuse. Adjacent to B over hypotenuse. So that's side A over C. And lastly, tangent of B is equal to opposite over adjacent. So tangent to B, opposite to B would be little b over adjacent, which would be little b over little a. Couple of patterns I hope you notice here. The sine of one angle is the cosine of the other. Vice versa, the cosine of one angle is the sine of the other. And the tangent of one angle is the inverse of the tangent of the other angle. They're reciprocals. Now, what becomes helpful to know at this point, before we move on, are three what are called special triangles. Let's make sure that we write them down so we can use them as necessary. There are more than three, but three we need for the physics class in particular. The first is called a 45-45-90 triangle, in which case we can write this, we can draw this as follows. We have a 45-degree angle, a 45-degree angle, and a 90-degree angle. And we can actually write and represent this two different ways. Most math classes will represent a 45-45-90 as this side is 1, this side is 1, and by using Pythagorean theorem, this side becomes square root of 2. Now, that's a specific way of writing a 45-45-90 triangle. A more generic way of writing it would be writing this as A, so A could represent any number, and the hypotenuse would be A times the square root of 2. The second triangle that's helpful to know is what's called a 30-60-90 triangle. Again, I'm going to represent that in a very specific way and a much more generic way. The specific way has the short side 1, the hypotenuse is double the short side, and the long angle is, or the long side, is square root of 3. In a more generic way, we could say the short side is A, the hypotenuse is double that, so that'd be 2A, and the long leg is A times the square root of 3. And the third one that's really helpful to know is a 3-4-5 triangle, which has the short leg 3, the long leg 4, and the hypotenuse is 5. That one becomes very helpful to know. On to the examples. Let's take a look at the trigonometry using numbers. Okay, in this assignment here, we have 5 parts. Now they involve the same triangle here, so we're going to recopy this triangle 5 times. Angle A, B, C. I'm going to recopy this 5 times, but each time I copy it, it's going to have specifically different information. Please pause the video and copy down those 5 triangles so that we can use them for the information given in each part. Okay, so the only thing we know is that angle A is 32 degrees. Well, I'm going to show all my answers in blue. The first thing we can figure out is that angle B must be the complement to angle A. So angle B must be 90 minus 32, which is indeed 58 degrees. Now, for the next part, all we have to do is take the sine, cosine, and tangent of 32, and then the sine, cosine, and tangent of 58. So put that in your, pause the video, put that in your calculator, and then we'll proceed. Okay, the sine of 32, you should have gotten 0.53. The cosine of 32, you should have gotten 0.85. And the tangent of 32, you should have gotten 0.62. Sine B, cosine B, tangent B, we're going sine of 58, 0.85. Cosine of B, cosine of 58 would be 0.53. And the tangent of 58 would be 1.60. Now for part 2, we still have 32 degrees given here for angle A, but this time we know that side A, which is this side over here, 112, this is side A, is 112. We don't know side B, that's a question mark, and we don't know side C, that's a question mark. Well, here's what we're trying to find. We now need to use our SOHCAHTOA, our ratios that we learned here. Sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. We are trying to find side B and C. Well, the problem is I cannot use a cosine function because cosine of A would be adjacent over hypotenuse. And you'll notice there's two unknowns there. That's not very helpful. Instead, I could use a tangent equation because tangent of angle A is opposite over adjacent. So tan 32 degrees equals the opposite side, 112, over the adjacent side, which is B. Now, in order to solve this equation, I'm going to use that little trick we learned called the switcheroo, where the denominator of the fraction switches with the other side of the equal sign. And B is equal to 112 over the tangent of 32 degrees. Put that in our calculator, round to the nearest whole number. We're looking at 179 centimeters. Now, once we fill out that side, this is great because now we have more information. To find side C, I can now use a cosine function because I have adjacent and I'm looking for hypotenuse. Or I could use a sine function because I have opposite and I'm looking for hypotenuse. Or I could use good old-fashioned Pythagorean theorem because I know this side, and I'm trying to find the third side. So a squared plus b squared equals c squared. I have a variety of ways in order to come up with my solution. I'm going to go ahead and practice with a sine function. So sine would be opposite over hypotenuse. So sine of 32 is equal to 112 over c. Again, we'll go ahead and do the switcheroo. That's supposed to be a c there, guys. There we go. And again, we get c is equal to 112 over the sine of 32. 112 over sine 32, and we get roughly about 211 centimeters. Part 3. Same triangle or similar triangle, but different information. Side A is 9. Side B is 12. We don't know side C. And we don't know angle A and B. So we got to figure that out too. Now, one thing we could do to figure out this right here is we could use Pythagorean theorem to find the third side. Right? We could go 9 squared plus 12 squared equals c squared and solve for c. That's one way to do it. Or we could realize that this triangle is actually just a similar version of this triangle. Watch. 3 times 3 is 9. 4 times 3 is 12. So if we use the same logic, that means 5 times 3 must be the hypotenuse, or 15. Right? And next to it, I can say I used a 3, 4, 5 triangle in order to come up with my logic. That right there is in lieu of showing your work. You're showing that you understand how to come up with the solution with a concept rather than actual mathematical work. Angle A and B. Now, how do I come up with those? Well, I know if I reference angle A, then 9 is the opposite side to A and 12 is the adjacent side to A. So I can come up with an equation that has opposite and adjacent. And that would be TOA. TOA is opposite over adjacent. So I could write an equation that looks like this. Tangent of angle A equals opposite 9 over adjacent 12. Now, I'm going to recopy it one more time but this time I am going to rewrite that as a decimal. If I go 9 divided by 12, I get 0.75. I'm going to leave a little space. 0.75. Remember what we did earlier in the exercise when we had the tangent of an angle equals a decimal. The tangent of an angle equals a decimal. What did we do? We took the arctangent of the decimal to get the angle, and that's exactly what we're going to do right here. We're going to take the arctangent, which is written as tan to the -1. We're going to do that to both sides of the equation. Cancels, cancels. We now know that angle A is the arctangent of 0.75. So put that in your calculator. Arctangent 0.75. And if we round that to the nearest whole number, we get, 36.8. We round it to 37 degrees. Right? That's 37 degrees. Oops. Now, angle B is complementary, so angle B has to be 90 minus 37, which is 53 degrees. Last step, just take the sine, cosine, and tangent of 37. Now, we could do this a couple different ways. We could just put the sine of 37, cosine of 37, tangent of 37, do that. Or you could do it as fraction. Now, to do it as a fraction, you would go opposite, which would be 9 over hypotenuse, which would be 15. 9 over 15, which is 0.6. And guess what? You get the exact same thing as if you took the sine of 37 degrees. Sine of 37 degrees is 0.60. You get the same thing. So I'm going to focus on it from a ratio of sides point of view. The cosine would be 12 over 15, which would be 0.80. And the tangent would be 9 over 12, which is 0.75. Part 4. We know angle B is 42 degrees. We know side C is 15 centimeters. We have to find angle A, the sine, cosine, and tangent of A. We already know we need to find the sine, cosine, tangent of B. Then we need to find side A and side B. Okay, let's start with the angles, because all that stuff's easy. Angle A would just be 90 minus 42. So 90 minus 42 is 48. So sine of A, we have the sine of 48 degrees. And we'll say that's 0.74. The cosine of 48 degrees is about 0.67. The tangent of 48 degrees is about 1.11. Now let's take the sine, cosine, tangent of B. The sine of 42 degrees is 0.67. Remember how we said the cosine of one angle is the same as the sine of the other? That means the sine of A is the cosine of B, 0.74. And go ahead and put the cosine of 42 degrees, and you'll see you get 0.74. And the tangent of one angle is the inverse of the tangent of the other. So if I take the sine, or the tangent, excuse me, of 48, and I get 1.11, if I take the inverse of that, I get 0.90. But I get 0.90 also if I just simply take the tangent of 42 degrees. I get exactly the same thing. So now let's focus our attention on those sides. How do we get those sides? Okay, now let me just quickly write these in blue. There we go. Okay. Givens in black, answers in blue. There we go. Okay, now, how about side A and B? Well, to do that, we're going to need to set up a trig equation, because side A, well, that's this one here. I don't know it. This is side B. I also don't know it. But I do know the hypotenuse, so I can set up a sine ratio with A, and sine of A is side A over 15. Opposite over hypotenuse. To get the adjacent side B, I could set up a cosine ratio. Cosine of A equals B over 15. And that's what I'm going to do. I'm going to go ahead and set up a sine and cosine ratio to go ahead and get those two sides. So first off, the sine of A is equal to little a over 15. Now, in order to solve for little a, you need to get rid of the 15. Since the 15 is in the denominator, I'm going to multiply both sides by 15. And this becomes little a equals 15 times the sine of angle A. Now remember, angle A was 48 degrees. So we're going to go 15 times the sine of 48 degrees. And if we do that, we get about 11. We get 11.1. We'll just round it to 11. I'm going to round it down. Side B, same thing, but this time I'm going to use a cosine ratio. Cosine of angle A is side B over 15. Again, ladies and gentlemen, to solve for side B, we're going to multiply both sides by 15. Why do we do that? Because multiplying is opposite of dividing by 15. And we get side B is equal to 15 times the cosine of 48 degrees. And 15 cosine 48 is about 10 centimeters. Now in this last example, we know all three sides. The hypotenuse is 13. Side B is 12. Side A is 5. We need to come up with the angles first, and then once we do that, we can get the sine, cosine, and tangent of each angle. Okay, so here's how we're going to do that. And there's a lot of choices you could make. I could go, now I'm going to focus my attention on let's just finding angle A first. I could say the tangent of angle A equals side A over side B. Tangent of A equals opposite over adjacent, TOA. I know both of those sides, so I could do this. Or I could go the cosine of angle A equals adjacent over hypotenuse. Or I could go the sine of angle A equals opposite over hypotenuse. In other words, when I know all three sides, I could use any trig function I want, sine, cosine, or tangent, and then simply do the inverse sine, inverse cosine, or inverse tangent to solve for the missing angle. Well, I'm going to go ahead and practice with tangent this one time, just because. First thing I'm going to do is I'm going to rewrite 5/12 as a decimal. So 5 divided by 12 is about 0.42. So this becomes tangent of angle A equals, I'm going to give some space, 0.42. To solve for A, I'm going to take the arc tangent, just tan to the -1, of both sides of the equation. Cancels, cancels, out pops angle A. And A is equal to the arc tan of 0.42. So the arc tan of 0.42 is about 22.6 degrees. I'm going to round this up to the nearest degree, so I'll say 23 degrees. So angle A is 23 degrees. That means angle B has to be 90 minus 23, right? They're complementary. So 90 minus 23 is 67 degrees. Well, that's easy, because now once we have those, we're going to take the sine, cosine, and tangent of 23. Sine 23 0.39. Cosine of 23 0.92. Tangent of 23 0.42. Sine of 67 0.92. Remember, the cosine of one is the sine of the other, right? The cosine of B is the sine of A, so that's 0.39. And the tangent of 67 is the inverse of the tangent of 23, which is 2.36. I hope you found this video tutorial helpful, and thank you.